back. I didn't do yesterday's LeetCode problem, so I'm going to jump in and do day number 10. And I'm going to go back. I submitted some for yesterday, but it kept saying the time was exceeded, so it was just like running out of memory. So I have to re-optimize it. And I also watched a video because it was really, really hard. So I will go back and do that. But this is day number 10 of the JuleetCode, and it's question 111, minimum depth of a binary tree. Haven't submitted anything for this yet. Kind of excited because it seems like something I've done before. So I just want to jump in. So here we are. Okay, so given a binary tree, find its minimum depth. The minimum depth is the number of nodes along with the shortest path from the root node down to the nearest leaf node. Note, a leaf node is a node with no children. Okay, so like this would be a leaf node, leaf node, leaf node, and then this would be like the root nodes. Okay. No, 5. Yeah. Okay. Okay. Number of nodes in this range. Okay, so those are the constraints. So we have to find the minimum depth of the number of nodes. Okay. So I feel like, I'm sorry, I'm also just waking up. I feel like we should just have a recursive approach to this because that feels like the way we should go. So we should start with if it's 0. I think it's always good to start off like if something is 0, then this. Then you don't have to like wait for the end for that. And then we should see if, we should see if both the left and the right child nodes are none, and then the minimum depth would just be 1. So like just like 1 here, you know what I mean? So let's go ahead and say if not root, return 0. That way, if the root is none, then the minimum is 0. Then we'll do the same thing with if not root left and not root right, then return 1. So then let's do if the left child is none, then we should be able to recursively calculate this, like the minimum depth of this right subtree. So yeah. No, root right. That's where we want to go. That's what I said. And then we want the plus because we want that to go. So then we should also do that for the right. So then it will, if there's only 1 and there's more over on the left, then we will continue to do that. So if not root right, return self min depth root left plus 1. And then so then if both exist, right, we need to basically recursively calculate like the minimum depth. So like if there's like, for example, let's say they both have children over here, we want to be able to recursively calculate the minimum depth of those, both of those subtrees. So let's do left depth. Then we're going to do right depth. And that should be self min depth, I think. And that would be for the root right. And then it'll be the same up here for root left. But then all we should have to do is return the minimum, right? Return the minimum of left depth, right depth, and 1. Okay. So that'll return the minimum of the left and right depth plus 1 for the current node. So like the node that it starts with. Okay, I feel pretty good about this. We're going to run it and see. Invalid syntax. Return O. Sorry, guys. Don't put the semicolon over there. I didn't mean to. Sometimes my brain, without caffeine, I actually just grabbed my caffeinated beverage and I haven't really had a chance to sip it yet, but I'm glad that we are passing these test cases. So let's go ahead and submit. Okay. She's looking, and it says day 1. I'm going to go back and buy a time traveler ticket and do day 9. Cool. Not my best, but I'm here for the vibe. The editorial looks like it's open, so we can take a quick peruse if it's not massive, and it is as per usual. Cool. Well, thank you guys so much for watching. I appreciate you guys watching these videos and hopefully giving me feedback eventually. And the GitHub with my solutions, the links to each of the videos in order is in the comment section. So feel free to clone or fork or do whatever you want. And if you have a better solution, go ahead, let me know. I'd love to see it. Anyway, thank you guys so much for watching, and I will see you in the next video.